Yes, I think we are live now. Hey, hi everyone. A very warm welcome to each one of you. I hope you all are healthy, happy, and safe from whichever the part of the world you are joining from. My name is Yash, and I lead the community efforts here at DeFi. Just to give you some context about DeFi, we at DeFi are a global data science community started with the vision to democratize data science education. And in our constant endeavor for the same, we keep conducting regular boot camps, data challenges, live sessions, and much more. Our today's session on NLP 101 is one such initiative, and our heartfelt thanks to Supriya for making it happen. I'm sure many of you would already know her, but for others, Supriya is a seasoned data science professional with more than 15 plus years of work experience. She's currently working at JP Morgan as the Vice President of Data Science, where she is responsible for developing predictive ML models, owning end-to-end life cycles for it, as well as accomplishing mission-critical projects for the organization. Not just that, beyond work, she also actively contributes to the community by taking live sessions like these, and as well as has been recognized as one of the top 10 data science women professionals here in India in 2021. So yeah, now without further ado, I'd like to bring her on and let her take over the session. Thank you, and over to you, Supriya.
Thank you, Yash. Thank you very much, and welcome everyone. A very good morning and a good evening to all the people. And today's session on NLP, we will do a quick introduction about what NLP is, how it is relevant in today's market, and I hope in 1 hour of the session which we have, we will have a great learning experience. With that, I'll start. I hope my screen is visible. So before we actually step into NLP and understand what is natural language processing, NLP stands for natural language processing, but before we actually start with what natural language processing means, let's discuss about how the communication of a human has changed with the machine over a period of time. So the first picture which I have here, long time back when we had punch card machines like this. So there were a punch card machine which used to punch the cards like this, and these cards were very bulky. At the same time, there were machines which used to read it. The second picture show the mainframe screen or the AS400 screen. Even in banking, mainly in the financial sector, this is still relevant. We have legacy systems where we have most of the core data being hosted on the legacy system. So these are very old system where if you have to do a small change in the system, you have to do a lot of regression. This still exists, but slowly and gradually, we stepped into something which is now the third picture I have is about the chatbot. Now you go to any domain or any platform, if it is online, you will surely have a chatbot and you will have a bot talking to you before you actually interact with the actual person, right? And the last picture I have is about the machines talking. So this is very relevant in all the, every home will have at least one of these. And we are so used to talk to these machines. So this journey actually shows how the communication of a human has changed with a machine in due course. Also to understand the data, how it has changed. So, they were early 2000 when actually the data started getting public. Earlier we had scarcity of data, but in early 2000, the stage came when the data started getting public. Even the governments of different countries, they started putting the sensor data and all on the net. So it started getting public, and when the data became public, it became huge. Not only that the data is huge, we have exponentially growing data. The data is growing in a very high exponential rate. So it slowly started with terminologies like data mining or data warehousing. We had data swamps, right? And then we came to data analytics. On big data, we have huge amount of data, you have big data, so you came with the data analytics on the big data. And finally, when you are trying to derive the insights of the data, at the same time you started with mathematical and statistical method of machine learning models which can be kept on these data to gain more insights. And then machine learning and data science came to the picture. So this is a whole journey. And when you talk about data, we have to understand that there are different type of data. We have images, we have audio, we have video, we have text, and so on. But the most common and most abundance of all these is something which we have is in the form of text. And thanks to social media, most of the platform which we have, we don't write the text in a formatted way, right? We don't have the formatted way of writing. So generally we go on these media and we type anything which makes sense, which is readable as a human, and we type it. So if we have to understand this bulk amount of a human readable format of text, then we need to have algos. And that's why NLP came into picture, which talks about natural language processing. If you have a natural language means a language which has been naturally generated out of human, you need to process it. That's what natural language processing means. Okay, so mainly talking about the area of applications which we have. The first picture here, it shows about the social media analytics. Now, social media, we have data all across, right? We have Twitter, we have Instagram, we have Facebook, and so on. There are a lot of platforms. We have blogs, a lot of blogs being written. So you have a lot of data. Now, just to give an example of social media analytics, if you are from India or also across, you might have known Rohit Shetty. Rohit Shetty is one of the famous director we have in Bollywood. Now he says whenever he launches a movie, right, he goes to the movie theater himself and he collect a first hand expression of how the customer is responding to his movie. That is very unique of him. I really follow him, and I really find it very unique that he actually reaches to the customer and he find out how on each scene the customer are behaving or how they are responding. But not everyone can be Rohit Shetty, and thanks to social media, because now we have huge amount of data. So you have this huge amount of data, you can make use of it, and then you can derive the analytics. You can build and you can derive the sentiments of the customer. Not only the sentiments, there are a lot of things which we extract out of it, right? The second example here is about banking and insurance. Banking and insurance are using machine learning techniques, both in deep learning as well as the naive way. There are a lot of there are a lot of applications in which we use it, like we have fraud detection, we have customer analytics, and so on. Just to give an example again, now when you apply for a loan in a bank, right, there is application form. You can see the picture. Now you fill all the details there, almost everything is boxed, and you fill your detail there. But at the end they ask you, why do you want a loan? And that is a human readable, it is meant to be written. You have to write some text there. That text is actually captured in order to capture the sentiment of a person. Although you already have all the data, then also the bank want to really capture that sentiment of why you really need the loan. This is again an example. The third one here is about automatic summarization. Now, we have talked about that how this data is exponentially growing, and none of us have time to actually sit and read through and summarize and grasp the important information out of it. So we surely need tools in order to summarize it. And there are a lot of tools which are relevant. There are methods like extractive methods. There are a lot of summarization tool which we have, by which you have large document and then you summarize it in a summary. The fourth one here is about speech to text. Now, speech to text, again, we can relate to Alexa or Siri or whatever version of it you have in your home. You just talk to the machine. And, we are so used to, you don't know anything and we don't actually go to Google and type it and find it out. We are so, Alexa, can you tell me? Alexa, can you tell me how is the weather today? So we are so used to talk about this machine. So this is how they process. They have our text. They do the text processing. From the speech, they convert it into text. From the text, they convert it into embedding. They derive the sense out of it. Then they form an answer to our question. And again, it happens. So there is speech to text and text to speech, which works there. The next application here is about image captioning. This again is very relevant if you are using Facebook. As soon as you put a new picture, you might have seen that as soon as you put a new picture, it automatically start tagging your people, whoever they might recognize. Now this is one level ahead of it. It is showing a picture where it is tagging actually all the words, and then it is generating a sentence out of it, and then it is marking a rank for each of these sentence, and then it is deriving which is the most relevant sentence which can represent this image, right? Chatbot, as I said, now just to give an example of chatbot, when the COVID started, right? I was working for Levi's, and there was a huge requirement. Now, if as a customer, if I go to a retail shop, I have a, I have a salesperson waiting there, and he can understand what I really want, and they can help me. But if I go to an online platform and I'm not so used to, right? I'm used to a salesperson helping me that whether you need this or whether you need that, this is a color which you want, this is a brand you want, this is a size you want. So you need an online attender for you, and then the chatbot became very relevant, especially in COVID. I think almost all platforms they introduced chatbots. And again, the sentiment analysis. Sentiment analysis is very similar to what I talked here in social media analytics. But in sentiment analysis, basically you talk about polarity. You talk about whether a particular text is positive for you or it's negative for you, and then there can be more final granular way of doing it, that which is more positive, which is more negative, and which is neutral. But basically you want to understand that when a customer is using your product, how are they interacting with it, and what are their say about your product. That is what sentiment analysis is. So we have some more applications here. Now, understanding the text. Now we have text, right? We understand that we have huge amount of text and we have to understand it. There are steps as a human also, if you have to understand, if you have been given some text which you're not across, suppose English is something which we are speaking now, but suppose I have been told to talk in Sanskrit, which is a very native language, and I don't know it. So how will I approach it? I will take that language, I will start breaking it into words, or I will try to understand the grammar of it. And then actually as a human, I will be able to grasp the meaning out of it. And same thing happens in even when we are telling the machine how to learn it. So basically, if you want a machine, the machine learning models which has been built, in order to make the machine learn the text and to grasp the meaning out of it, there are three important steps which we have. The first step here is about the lexical processing. It talks about the text itself. It is basically you have the raw form of the text. You have just the raw form of the text. From that text, whether you can find some sense out of it. And what we do with the raw text in this step in the lexical processing here is we break the text. So first we do that breaking of the text in words or sentences or paragraph is something called tokenization. We will go in more detail about tokenization in further slides. But what I meant to say in the lexical processing, you have a raw text, you have a huge amount of raw text, you break it into chunks. The chunks can be as small as a word level or a sentence level or a paragraph level. And then you try to understand the meaning of each word in solace. You don't associate the words together, but you are just trying to understand the meaning of each word. The best example which I can give about lexical processing here, the first step which we are discussing, is spam ham detection. When you have to detect the spam detection of the mail, you have emails, right? You have a bulk of emails. Now you have to detect, it happens automatically if you're using Gmail, right? There is a separate folder where it actually collect all your junk mails, right? You have a main folder, and then all those mails which the system consider as a spam, they are collected into a spam folder. How do they do that? So they actually go through each of the words. They break the whole context of your email into text, into pieces, and then they try to understand the meaning of each words, and then then they classify it into spam and ham. The next step of it, this is about lexical processing. The next step of it is about syntactic processing. Now, once you have understood the words, from the text, you broke it into pieces where you understood each word or each fragment of it separately. You try to associate the words now together. So you try to understand the language of it, and then came the syntactic processing. When you try to understand the language of the sentence, you have pause tagging. Pause tagging is part of speech tagging, which is very relevant. Now, again, to give an example, right? Suppose you go to someone and you say, "Give me water." Okay. Now, as long as I understand that give is a verb and water is something as a noun, and I can understand them together, I can form the meaning out of a sentence, because I know now that what is a part of a speech. Give is a verb, water is a noun, and I can together associate the meaning of two of them, and then I can find the meaning of the whole sentences. So in syntactic processing, basically we try to understand the meaning by using part of speech, pause tagging, and we try to understand a language out of it. Also, there are subject and object association, which we do here, right? So again, to give example, like two sentences, say Shyam thanked Ram and Ram thanked Shyam, right? These are two sentences, but their meaning is different, right? If you go by lexical processing and you tokenize it, the tokens of each of both these sentences are actually the same, but the meaning is different. The meaning is different because which is a subject of the sentence changes. In the first sentence, when you say Sham thanked Ram, Sham is a subject. In the second sentence, when you say Ram thanked Sham, Ram is a subject. So, it's subject or object coordination. Pause tagging is something which we use in syntactic processing. The third step which we follow in text analytics is semantic processing. Now, what happens is sometimes the text which has been given to you is not enough to understand the whole context, right? And in order to understand that text, you need more text, you need more references. For example, again, to say, suppose I say cat, as soon as I say a word cat, as a human we can frame a picture of cat, because we know, we have this knowledge of how the cat looks, right? We can frame a cat in our mind and we understand. Now if I say a sentence like cat barks, you will not agree with me, right? You will say that cat doesn't bark, you will not agree. So same thing, like, you have text, but whether you can understand the relevance of that text, you need more information out of it. And that's why when we are doing semantic processing, we need extra references like general knowledge. Now, general knowledge can be, suppose there is a huge text, right? And there are mention of word PM and Prime Minister. As a human, we understand PM and a Prime Minister is same. But can we make that model also understand that? That is what general knowledge means. Domain knowledge is specific, like again, to give example, if you're dealing with medical terms, right? Medical terminologies, if you're dealing with some documents which deal with medical terminology, there are a lot of taxonomies specifically for the medical terms. Now, in order to understand that, you need more references. So that domain knowledge should be supplied in addition to the text which you have. And discourse context here means where the same word means two different things in different contexts. Again, to give example, I can do this, and can, in this sentence, I can do this. Can is a verb, but can also be a can where it is a noun, right? So same word in different context of the sentence can have different meaning. Can that discourse be defined in the text when we are making a model for a machine? That is what discourse context means. So together we talked about three things. We talked about lexical processing, we talked about syntactic processing, and then we talked about semantic processing. These three steps together form the main way how we make the machine understand the text, right? And then we have different applications which we already talked about, right? We already talked about some of these applications. On the right side of our screen, we have the shallow, and now the shallow and the parse is something, again, these are the terms which are associated with NLP, natural language processing. So we start with text, we break it into speech, phonics, and then we will talk about lexems and syntax, and then semantics we talked about, and then you associate the discourse context. So you start with something as shallow as text, and then you go as deep as the discourse of it. That is what the text analytics is all about. Now, again, the semantics part we talked about, right? We have to associate different meaning. This is just a funny example, but talking about the semantic processing again, think of the translations which are being done, right? We try to translate one language to another. Many a time the translation fails because you do a word to word translation, it will surely fail because the context of it is not relevant. We will see an example of semantic processing where we do the translation in a few slides. Now, these are some of the questions, but I'll just go through these and I'll explain it. This is the first example. The first example here says that you have two email messages, and this is how the email message, I have just extracted the word out of it. So the first email have the words extracted as the, hurry, exclamation mark, and lucky, while the second email has the word the and offer and sale. Now, just using this information that these are the words, can I determine whether this is a spam message or not? So surely if you see the first one, you have a lot of junk, you exclamation mark and all, and also the words which are here, it will automatically classify it as a spam. So this is an example of lexical processing which we discuss. The second example here we discuss about is our Alexa, Amazon Alexa, and now you go and tell Alexa that book good dentist. Now, as long as Amazon Alexa understand that book is a verb, good is an adjective, and dentist is a noun, it will be able to associate these three words together, and it will have able to help you book a good dentist, right? So this is an example of your syntactic processing, right? Just to go back, so we talked about lexical processing and the syntactic processing. The last one is about the semantic processing, and this is what I was talking about, the translation. Now, when you translate one language to another, it's a very funny translation. So this is a Google translation or some app translation which has been shown that it says, I cracked the interview, and in Hindi, for those who don't understand the Hindi, I will translate it in English. It says that it broke the interview. Well, a crack here, it simply means he has cleared the interview. So what went wrong when the translation has happened? What went wrong is it's a word by word translation, although the syntax of it has been translated properly, but the semantic of it has not been added to it, and that's why it is failed. So this is about an example of the semantic process. The next slide I have is about the deep learning. Now, whenever we talk about text analytics, right, there is no more a naive way like how we talk, right? There is no more just the past, these steps are no more being done by the native libraries. Now we have stepped into deep learning. So most of the part of the semantic processing which we have is being done by the deep learning. And how do this deep learning works? There are a lot of models. We will talk about deep learning in a few slides, but basically in deep learning, there are a lot of models which has come up. Like it started with the neural network and reinforcement learnings, which we have, but now we have more advanced like transformer based models. We have encoder decoder models. For example, we have BERT, digital BERT. There are a lot of models which has come up. And actually, so we already understood that text is huge, right? We already have huge amount of data. The only condition which we have for deep learning is your data should be very huge. As long as the data is huge, you can feed that and you can train your model. Deep learning works better when you have huge amount of data, and fortunately in text we already have. So deep learning works with a better accuracy when it is trained on a huge amount of data, and that's why the native way of doing the text analytics in many places are now getting replaced with deep learning. So most of the projects which we do now, we start with the basic lexical processing and syntactic processing using the native libraries which we have, but at the same time we also amalgamate a lot of deep learning models so that our task is easier. These are mainly pre-trained models, so you don't have to train it, because it is pre-trained. You just have to use it, you have to modify, fine tune it, and then you can use it. So just to explain deep learning, when you say deep learning, it is a combination of two things. It's about neural network and the reinforcement learning. Now, in this picture, the first picture which you see is about the neural network. You have a picture like bird. and your model should take this picture, any picture for that matter, and it should predict whether it's bird or something else, right? So how it happens in neural network, unlike the traditional machine learning models, we don't do feature engineering. Okay, we don't do feature engineering because in a picture you cannot define, there are so many features, how can you quantify it to a model? So the features are not defined by us, the machine itself take these features, and which feature to to consider, which feature not to consider, it has been determined by the weight which the model learn itself. So as a modeler or as a data scientist, I just have to define some hyperparameters to this model. The parameters for each feature is been learned by the machine, by the model itself. Some of the neural network which we started with is ANN, CNN, RNN, where RNN had LSTM and all those models. But now, as I said, there are better models which are based on transformer, encoder, decoder. We have, as I said, some of the work which I am doing now is based on BERT. So there are better ways of doing it. When we come to reinforcement learning, I will give an example of robocar. Okay, think of a robocar. Now, what happens in a robocar? There is always an agent. So in a robocar example, the agent is your car, right? So agent will always take an action. That action will happen on the environment. So for a robocar environment, you can think of the surrounding, the road where it is driving, and all those things. So agent will take some action on the environment. Based on any action which an agent take, there will be a reward. The reward can be positive or negative. So for a robocar, the reward can be, the action can be it drives to some distance, and the reward can be, might be it made an accident, or might be it reached 100-meter ahead distance, right? So the reward can be positive and negative, and with each action which we take, we land up in a different new state, right? So this is self-learning models. You have an agent which is doing some action on the environment. Based on each action which you do, you have rewards, and you land up in a new state. And then these model, they self-learn it, and then self-train it. So coming to deep learning, as we said, you in the traditional machine learning model, you have feature extraction, then you put the machine learning model, and then you find the output. In the deep learning, you generally don't do the feature extraction. Feature extraction is done by the model itself, and also which feature is more important has been determined by the weights by the model itself. Okay, so coming to the text encoding now. Any questions I have, Yash, which I have to address now, or can I proceed?
Yeah, I think Supriya, you can proceed. So far, it's going smooth. Yeah, please proceed.
Okay, fair. So now talking about text encoding. Now we talked about we have huge amount of data, we have to feed it into machine, but we also have to understand that the machine does not understand text, because text is something alphabet or might be alphanumeric, but machine does not understand alphabet or alphanumeric. So there should be methods by which we encode it, right, in a numeric form, because machine only understand numbers. So how will you do that? So basically what happens for each of the text, each of the fragment of the text, we will talk about tokens in a few minutes. For each token, you generate embeddings. Embeddings are nothing but a matrix of numbers which represent each of these tokens, right? And then we feed it. So in order to generate these embeddings, we need text encoding. Now there are different methods of encoding which is relevant. ASCII is most popular and most, it is from 1970s or somewhere. It uses 256 bit of encoding, and that's why, because it's only 256 bits of encoding, most of the character which it can encode is English character. It cannot encode much of foreign language characters. And that's why, because it has a limitations, UTF came into picture. So we have two form of UTF, Unicode. We have UTF-8 and UTF-16. UTF-16 always takes 2 bytes of storage, irrespective of any language. While UTF-8, it take 1 byte of storage for English character and 4 bytes of storage for any other character. So again, we are talking about encoding, but as a programmer, I don't have to worry about encoding, because encoding are smartly done by the model itself. It is automatically taken place, but it is just to explain that when you are dealing with text, although you feed the text to the model, that text is not taken as is. First, it gets encoded in form of embedding, and that's how the processing starts. So these are some of the examples about, you take any character and then how the ASCII code looks and UTF-8. Again, this is not something which we have to generate and we have to take care of it. It's automatically done by the model, but just for our understanding that it has to be encoded. Another important word or the terminology which is relevant in NLP is corpus. So when we say corpus, we simply means a huge collection of text. Okay, the huge collection of text can be from anywhere, from any source, and as long as those text can make sense and can be feeded into the model, that is called a corpus. Now, the most basic library for NLP, natural language processing, is NLTK. NLTK is based on Penn Tree Bank. Penn Tree Bank is one of the corpus which has been given by Wall Street journals. This is what is being used by default. If you use NLTK library, by default, it will use this corpus. But then there are a lot of other corpus also, as I listed. There are a lot of corpus which is relevant. Also, I talked about domain knowledge, where you have specific terminologies, especially if you are dealing with medical terms or banking term, financial. Even with the retail, there are different type of terminologies which they use, right? So if you have a specific requirements where you want to attach a corpus, then you have to specifically take this corpus and then you have to attach it in a model, and you have to tell your model that this is the corpus which you have to use when you are um, operating onto it. So that's what the corpus means: collection of huge amount of text. The first and most basic way of dealing with text is regular expression. Now, what happens? There are many complex. We talked about deep learning also. So there are many complex ways also to refine the text and understand the meaning out of it. But the most basic of all is what we have as a regular expression. Now, what happens in regular expression is, as long as you can define a pattern, you define. Now, suppose I have a huge amount of text, right, and I just want to read the numbers. So I tapped some data from social media. Might be I tapped some data from Twitter, or might be any media I tap, and I just want to capture phone numbers out of it. So I know that the phone numbers can only be 10 digit numbers, right? It can only be numbers, and it has to be 10 digit. So I can define an expression for it, right? I define that these are digits only, and it should be, the length is 10 digits. Similarly, if you are talking about Twitter, right? Twitter has handles, right? You have hash characters, right? You tag it. So Twitter handles always start with a hash. Again, I can define an expression out of it, that it should always start with a hash character, and then it can be of any length, right? So what regular expression means is, as long as you can define a pattern for a certain substring, you can define a regular expression of it, and then you can define that regular expression and take the help to manipulate that, or might be manipulate, or sometimes just extract the information out of the text, right? So regular expression, I'm not going into detail of it, but there is a basic library again, which is regex. Regex is the most basic library which we have. There are other, like if you go in PySpark and all, regex is embedded with PySpark, so they are more efficient when you work with advanced libraries. But the most basic library which we have for regular expression is regex, and there are a lot of there are a lot of quantifiers which has been defined for it, and a lot of expressions which you can use in order to define your own regular expression. You can use those, define your own expression, and just do basic analytics on the text. This slide is very interesting. This is about Zipf's law, and this is a research which has been done by one of the scientists, which is called George Zipf. Now, what George Zipf says that as long as your document which you have taken is not very small, it should have adequate length, because if it is very small, the information itself is shrinked. So your document should be huge enough. If you have a self-sufficient document, it's a good length of document, what he did, he found, so he took any of the document, you take any document, and then you list all the words. So you take all the words like this. So these are the tokens. He took all the words out of it, and he counted how many frequency of each word is. So if you see, this is just an example. So might be some document, it contained the token D this many times, right? This is the count. And token F, the word F comes this many times. So these are the words which we have in that document, and these are the frequency which we have. Okay. Now, the graph which we have here, right? If you see, so this is the frequency of the word, and on the x-axis we have the rank of the word. Now, rank of the word is 1. The first rank is given to the word which is the highest frequency. Now, if you see this example, the word "the" has the highest frequency, so it will get a rank 1, and so on. You know, the rank will go on decreasing as rank will go on increasing as your frequency will go on decreasing. So what he says, according to Zipf law, you take any document and you try to do a graph like this. You plot the frequencies of the word, then you plot the rank of the word. You will always get a graph like this, which is a very skewed graph, which you can see the blue line here, right? It's a very skewed graph, and this is how it looks. So what it says, if you see only the blue line, this is a word distribution graph. It says that irrespective of any document which you take, there will be a huge number of words in that document which will have a very high frequency, while there will be a huge number of words which will have rarely occurring ones. These are rarely occurring words because they are rarely coming into the document. So this is a graph which you will draw, and this is a word distribution graph. At the same time, we also have word significance graph, and this dotted line here, it represents the word significance. So word significance, irrespective of any document, it follows a normal distribution. Okay, so we will not go into how the word significance comes into picture, how it has been derived. For now, we will just keep it as it is a normal distribution graph. But going back to word distribution graph here, right? So, these cutoffs, if you see the cutoffs now, as a cutoff, the cutoff is taken by, it is human decided cutoffs, and again, these are not something which we have to manually do. So these are model generated. When you do the model itself decides what the cutoff is, and it will tell you what are the high frequency words. Okay, so the high frequency words, if you see the high frequency words which we have here, these are words which does not make any sense. If your word has very high frequency of these words, the, of, to, and so on, these words are actually the words which are called stop words, because although they are a huge number, you cannot derive any important meaning out of it. That's why it's called stop words. And also they are rarely occurring words. Now, to give an example of rarely occurring words, suppose I'm reading an article on Sachin Tendulkar, right? Somewhere in the document, 2 or 3 times, it says that he went to Kenya and he played some match, right? Now, because I'm more, I'm reading the document for Sachin Tendulkar, might be I'm doing some analytics onto his history. I'm not worried about the word Kenya, because although it might have appeared 3 times, it is not relevant for me. And that's what rarely occurring word says. It says that these are the words which are rarely occurring in the document and will not be relevant, so you can just discard it. Okay, so again, as I said, high frequency words are something we have stop words, and we have also rarely occurring words. And then if you exclude both of these, then in between these, right, in between these are some word which is this shaded part are actually the word which you want to extract and you want to do the analytics onto it. So these are the significant words for you. Now, again, these are not done manually. These are done by the model itself. This is just understanding, and this is just to explain that although the text is very huge, the text is very large, we have to shrink it. And this is one way, because you don't want to do the processing on the whole text, whole world of text. You want to shrink it, and then you want to do the processing. So you have to find out what are the significant words, which the model itself will do it for you, and then you do the processing. So we talked about high frequency word, we talk about significant word, and we also talked about rarely occurring words, right?
Supriya, there is a question from one of the learners, if you can answer that.
Yeah.
Yeah. So she asked, like, I think in the previous slides we mentioned about certain libraries, NLTK, Regex, etc. Right. So the question is around, like, do these libraries work for internet slang and emotions, emoticons, basically? Yeah. If you can.
Yeah,
Right.
yeah. That's a very good question. So yes, NLTK, I will talk also about it. NLTK has some basic where you have, it works or in emojis. We have tokenization and stemming lemmatization. The basic processing of it always is there in NLTK library, and you can also do it using regex. I will give you some examples also in the coming slide. But as I said, NLTK is the most basic library. You have better ways of doing it, you have faster way of doing it. So it depends, when you talk about faster way of doing it, it's always attached with the cost, and it also attached with the accuracy, how much accuracy you need, how much cost you can incur, and whether you need such relevant library, or you can work with a normal library and you can work with the normal accuracy, is something which you always have to take a decision on. So yes, to answer this, NLTK library has some basic way by which you can deal with the emojis and Twitter, Twitter handles and all. But then there are other better ways also to do that.
Cool. Thanks for answering that. Yeah, yeah. You can continue probably.
Thanks, Yash. Okay, so the next slide we have is about the tokenization. Now we kept on telling, right, that we have a huge amount of raw text. We want to understand the meaning out of it, and in order to you cannot understand it unless you break it into chunks. So you have to split your text into smaller elements. Now your smaller elements can be words, it can be sentences, or it can even paragraphs. It depends on how you want to break it. A simple example of it is shown in the picture, and this is what tokenization is. This is word tokenization. So you have a sentence. When I say tokenize, you are breaking it to word, and each of these words is now your token. So if you see, again, giving example from NLTK, you have 4 ways by which you can tokenize. You have word tokenizer. So you take a huge amount of token, you use word tokenizer, you will split it into words. You can also do a splitting on a sentence, where you have sentence tokenizer. Coming to your question, yes, you have Twitter tokenizer also. Now, what is tweet tokenizer do, and how it is different from the word tokenizer? See, if you take word tokenizer and tokenize it on some Twitter content, then suppose you have words starting with hash, right? If you have hash and say Yash, right, or hash JP Morgan, right? Now it will take that as a word, right? Hash JP Morgan is one word, or hash whatever, hash NLP is one word. But actually, you were just want to understand NLP, you want to extract NLP out of it. So Twitter tokenizer are very smart. They understand your hashtags separately, and then they tokenize your words. Similarly, you also have regex tokenizer, where you tokenize it based on the regular expression. You can define your own regular expression, and you can tokenize the word. This is more significant if you have a huge amount of data and you don't want to process the whole amount of data. You only want to look into that part of that text which matches your pattern, right? So again, going the example which I talked about, you have to extract say 4 numbers. Now I know the pattern is only 10 digits. So instead of just going through all the text and wasting my time processing the whole amount of it, I can define my own regular expression, and I will just work on 10-digit text which can be extracted out of it. So that's how it's regular tokenizer works. So you can have different type of tokenizer, and then you can break your whole text into smaller chunks. Now coming to the bag of word. Now before we go to bag of word, see, there are better ways. We understood that the text cannot be directly fed into the machine. So we need some kind of embedding, we need some kind of encoding, and we need some kind of representation. There are a lot of libraries which we have, which do the tokenizer. Even the bag of word, you don't have to manually create it. This is just for our understanding how the bag of word works. But you already have a library and a bag of word get created. So basically, when you say bag of word, you are trying to create some kind of embedding for your text by which you can feed it into the model. Okay, so this is just a basic understanding. But this is not how the bag of word is getting created. There are many advanced ways, there are better ways of creating the embedding, and this is just for our understanding. So just to understand the embedding or bag of word from the scratch, you have three documents for example, right? And for our simplification, we just assume that each of these document has only one sentence, right? Now, if I have to create a bag of word for each of the document, what I will do first, I will remove the stop word. Now we all understand stop words. Stop word are something which is a high frequency and does not make sense for us, right? So we just trim that off. It can be easily done by using the libraries. And then we take the words. Now the words which we have in the table is a significant words. We talk about significant, right? The zip law, the in between, the center part of it is our significant words. So we have just taking the significant words, and then we are creating a table. So these 1, 2, 3, the rows which we have is corresponding to the document which we have. And for taking example of row 1, it says actor 0. That means in the first sentence the frequency of the word actor is 0, while great appears 1 time, depends appears 0 time, and so on. So this is how you create a bag of word. This is one way of creating. The other way of creating a bag of word can also be based on your frequency. Instead of just putting 0 and 1 in order to indicate presence and absence of that word, you can also put a frequency of that word. So if the movie comes twice in my sentence, instead of just putting 1 in order to indicate it is present, I'll place 2 because it occurs twice in my sentence. So as I said, there are different ways of creating the bag of words. So basically you create a bag of word, you create the embedding, and then you start the model. Okay. Going to the next topic which we have is about stemming. Now this is again very significant when we are doing lexical processing. Basically you have words like this, right? You have word like warm, warmer, warming, and warmed. Now although these are different form of the word, until you just want to go and do some language processing onto it, if you are just if you are just worried about understanding the word itself, you're doing the lexical processing, you need not have the different form or the different format of the same word. You can just compress it back to a single format. How it will be helpful is it will reduce the big bag of word which you have. In the bag of word, I don't have to store 4 different word. I can just store warm, and I can store the frequency of it. Okay. So basically the base word of all these word is warm, and the base word of the word in which we can transform it is called stem. Okay. So when we talk about stemming, basically you are trying to reduce a word back to its base form, which is called stem. And how we do it is, some of the examples is given here. The stemming works by trimming on the right side. Okay. So you have a word, in order to reduce it to the base word, you always trim it on the right side. So if you see here, you have caresses, and it goes to, because you have the rules defined. You always have, in the stemming, you always have the rules defined. Based on the rule defined, you always trim it on the right side. And that's why there are errors which happens in stemming. So if you see ties and tie, ties and tie has been reduced according to the rule which has been written, but actually the base word is wrong, right? Ti is not correct. It should have been tie, but because we have a rule defined like this, it has got a wrong stem. So that can happen when you are doing stemming, but overall your word will be reduced to a smaller bag of word, and you will have a faster processing. Again, these are examples. There are different type of stemmers which you can use, and you can do different type of processing. The other way of doing, reducing it to the bag of word, reducing it to the base word, is lemmatization. So we talked about stemming, where you have, it actually works by trimming on the right side, right? It reduces the suffix, and then it get the base word. In lemmatization, the base word is called lemma, right? And this works on lookups. There is no more trimming, there is no more rules which has been defined, but you have a dictionary, or where you have a lookup where it looks and it find out what is the root word. So it's just an example which I've given in a table, but you have bigger tables like this, where you have a lot of lot of word variations of word which you can have, and then tells what will be your root word. So just to give a difference between stemming and lemmatization, both of them try to reduce the bag of words. You try to reduce the word to its base form. But when you talk about stemming, there is a trimming on the right side and there are rules defined. While when you talk about lemmatization, it is basically going to a lookup table and finding the base word. And because lemmatization want you to go and look into some kind of dictionary and find the base word, it is more time taking. Many times lemmatization take more time taking, but it is more time taking, but it never creates a junk, because we saw in stemming, right, we create some junk words when we are trying to reduce it to stem. But lemmatization, you will never have some junk created because the root words are already mapped into the dictionary. Okay, now the last topic of the session we have is why NLP is hard. Now, when I say hard, it doesn't mean that it's tough or it's something which we cannot implement. It's just that you have to take sorry for that. You have to take extra effort or extra precautions when you're dealing with text, and you have to give special importance to these things when you are doing text analytics. Okay, so the first thing here is about ambiguity, right? And we talked about it. We have word like can, or for example bank. Now bank can be a financial institution, right? Or it can be a river bank. Now both of these are actually noun, but in a sentence, if it has been used, how will you make your model understand whether which bank you are referring to? It's no more a part of speech, it is about the word sense. Similarly, we talked about can, right? You have noun or a verb. So at least for this part you can do pause tagging, but for words like bank, where you can have different, you need discourse context, right? The second thing here is about a complex language than English. Now, what we talked about is whenever we are doing any kind of processing in any kind of text, the first thing which we do is take the raw text and break it into pieces. That's what we call tokenization. Now, there are languages like this. There are some examples which has been given where you don't have ample space to do a tokenization. Now, until you can break into small pieces, you cannot generate an embedding out of it. You cannot understand each word in separation. So how will you tackle those things? You need extra complex models for that. Unknown representation, again, there are representations which are clear as a human, we know and we understand it, but how will you make the model understand? The fourth one here is about expression. You can say same thing in different ways, right? And if you see the example, none if you do a tokenization of these two sentences, none of the word will actually match. But as a human, we understand that both these sentences mean the same. You have to embed the same quality of machine learning to make your model also understand that actually it means the same, right? And that's what happens in when you do speech to text and all, right? You have to take extra effort. So that's why the lexical processing does not works here, because although you break it into small chunks of token, you need more processing out of it in order to get the expression out of the sentences. Then unmodeled variable. Now this picture shows that rat is smaller than elephant. Now if you see these two picture, as a human we understand that yes, rat is an animal and it is always smaller than elephant. But when you're doing a modeling, or when you're doing a text analytics and you have some text around this, can you make your model understand that rat is actually a smaller animal? How will you make the model understand that? And the last one here is about the sparsity. We talked about Zipf's law, right? And we saw that most of the text which we have, there is a huge amount of word which are actually stop words. These are words which are very frequent, but we don't need to have them. We have to remove them before we actually process it. Okay. And not only that, sparsity, when you talk about sparsity, most of the words are not well formatted words. When you're talking about social media, for example, you talk in social media, right, and for okay you write k, or anything, they are different. You, for you write just you, right? So how will you understand whether what are the base word and how to remove this word, whether this is sparsity or these are stop word, and how can you remove those. So those are extra things which we have to consider when you are dealing with text analytics. With that, I come to end of my presentation, and I open the forum for any questions which I have. Yes, do you have any questions for me?
Yeah. First of all, like thanks Supriya a bunch, like for taking such an intuitive session. I think the audience were enjoying it thoroughly, and hope like all the basics and other stuff is clear to them. There are a bunch of questions which learner has asked. One of the questions is like like we talked about various NLP frameworks, right? So how do we generally go about like selecting them? For example, NLTK over Spacey, and like if you can throw some insights on them.
Yeah, so as you mentioned, right, there are different, as I said, there are different ways of doing NLP model, and there are what to wake glow. There are even the deep learning models which we talked about, right? And then we had transformer model, encoder, decoder model. There are a lot of models which are available. Now when we have to actually take a model, when we actually have to take a model for a text analytics, there are two things which we have to consider. What is the cost attached to it, and as I said, what are the accuracy which you are expecting. So if the text is something like spam hunt detection, and I can do it with the basic model, I don't need to put a very complex model there, because even a basic model can help me do that. But there are models where you actually want to understand the sentiment of the of some social media, or you want to have a very accurate prediction of what is being what the text means. If you go with the accuracy, how much accuracy you need, and with the high amount of accuracy you need, your processing will increase. So if you talk about any of the deep learning model which you talked about, it is something which will not go on your CPU. You cannot take your CPU and just run those models, right? Because these are pre-trained models. You have to do fine tuning on it, and you will need at least a GPU or TPU to execute it. So which model to check for, it depends on how much accuracy you need, how much of data you have. Again, if you have a small set of data which you can use to train, your deep learning will fail there, right? So it depends on what kind of data you have and what kind of accuracy you are expecting, how much processing or how much cost you can incur for that, and so on.
Got it. Thanks a bunch, Supriya, for answering that. One more question, from Spinias. He asked, do you have any recommendations for beginner to intermediate level books for learning NLP or NLU per se? If you can share some recommendations.
Books are there a lot, but I will not, I will not be able to, because I'm not a book person. Generally I go by videos. I follow a lot of videos, I follow a lot of blogs. So my way of working, I'll say, you can never be an expert in this field because there are researches going on. The moment master yourself in one model, you will have a better model working there. So how I master this field is I go by the blog, and I do read a lot of blogs around the researches which is being done. Now, these blogs will not give me an end-to-end pictures of what is being done, but at least this blog will give me an overview of what the model is and how. So even the new research papers which comes, there are a lot of blogs which are written only on the, obviously you have the actual research paper. If you are keen enough, you can go and read the research paper, but I'm not a research paper reader because it's too complex to understand for me. So I generally go and read the blogs, and I hear them in videos. And then, suppose I talked about transformer, right? And if someone is not across what transformer is and how the transformer is being used into natural language processing, you can start reading it with a small blog, or you can start finding it with a small video about how the transformer works, and then you can explore more onto it. If it hits you, and if it's something which you really require for your work, then you can explore more of it. But that's how I approach. I am not a book kind of person, so I will not be able. And it's very difficult to assign one book, because as I said, text analytics is no more a native way of dealing it. We have deep learning now, so that's how I take up. Yes.
Got it, got it. So Priya, if you can name those blogs, I think that would be really helpful for the learners, so that after the session they can go through and read those blogs.
Yeah, so there are a lot of blogs. The two of them which I read, I always make it a point to read, is toward data science and medium, and even analytics media I follow a lot. I make it a point, I read at least two blogs a day. These
Mhm.
are about some blogs which the work which has already been done. These are some basic, they write blogs for everything. They can be very small topics which you want to explore, and then they write blogs onto it. But for the research, there are a lot of blogs, like a research paper, like there, for just to name it, there is a 2-minute paper blog which is there. So any research paper they take and they talk about it for 2 minutes. That's how the blog is. So those are one which I follow on a regular basis, and I keep myself updated.
Got it, got it. Thanks for answering that, Supriya. I think that would give some insights to the learners. The last question, which is there is how that's something which I personally want to ask. How can a learner or a beginner can go about hands-on implementation of NLP? If you can share some roadmap or some guidelines on how can we approach it, that should be good.
Yeah, so see, there are different ways. One way of learning is you are put into that project in your. That's how I learned, because I'm a old person, and I have been data for a long time. We had text and we have to start with. That's how I learned. So I started with A, and then B C D has to happen because I have to find a better way of doing my work. That's how I did it. So I kept researching. But if there is a learner now and they want to start with, there are a lot of YouTube blogs. There are a lot of YouTube blogs which actually have created a series of NLP. Um I have not gone personally, truly speaking, because I never get so much of time. But I have seen it, that there are series of YouTube blogs, to YouTube videos which are made around it. That is a better way of doing it. Other way are, I'll say, there are a lot of courses also. If you have to be very systematic, and if you have to be very trendy with everything which is relevant in the marketing, you want to read it, go through a proper course. Because if you are exploring yourself on YouTube, you might take a lot of time understanding whether this is more relevant or that is more relevant. It takes a lot of time. If you want to learn everything which is relevant in the market in a very short time, and you want to be very systematic, do some course, is what I will say. And most of the courses which are now being provided, I think they are very compact, and they keep very, the content is very up to date with the market. So if you have to start with, I'll say that is the way to start with. But if you are already in this field and you want to build onto it, then, as I said, read blogs and try to see the more research papers. Because when you're working, there will be a way of doing it. But when you keep reading these blogs and keep reading, updating yourself with the researches which is being done, you will find n number of other ways of doing it, and then you can slowly incorporate it in your own work. So there are two approaches. If you're new, go with a systematic learning. If you are already there, then try to build on it.
Makes sense. Totally aligned with it. Thanks, Supriya, for addressing that questions. And I think, yeah, that's pretty much for the session. Really enjoyed it thoroughly myself, as well as I think, the learners also enjoyed. There were thank you messages popping in right now on the chat. So yeah, thanks everyone for joining the session, and thanks Supriya for taking your time and delivering such an intuitive session.